Hey everyone. What if I told you that there are valuable secrets, incredible insights hidden all around us in plain sight? Well, that's exactly the promise of data mining. It's the art and science of discovering these really unexpected patterns inside just massive amounts of data. Think of it like being a detective, right? But your crime scene is the entire digital world. And today, we're going to crack the case. So let's just jump right in with a classic question from the world of data science. What do hot dogs, ketchup, and beer all have in common? Now, I know it sounds like the beginning of a really bad joke, but the answer actually reveals the incredible power of data to find connections that we would just never ever spot on our own. So hang on to that thought. We are definitely coming back to it. The whole reason we even need something like data mining is because we are, right now, living in a total data deluge. We're just swimming in information. I mean, think about it. Social media posts, sensor data, every time you shop online, it's a literal ocean of raw material, and we need some way to navigate it and make sense of it all. But here's the real kicker. A huge part of this information isn't organized in neat little rows and columns. Nope. Some people estimate that up to 85% of an organization's data is what they call unstructured. We're talking about emails, images, all those social media posts. And this messy, chaotic data, that's precisely where the most valuable insights are hiding. But of course, it's also the toughest stuff to analyze. When people talk about this challenge, they usually break it down into three parts, starting with volume. And I mean, forget about spreadsheets. We are talking about billions, maybe trillions of rows of data, a scale so massive it's almost impossible to even wrap your head around. Then you've got velocity. This data isn't just sitting there. It's being generated at an absolutely incredible speed. Just think about stock market trades happening every millisecond, or a social media trend that goes viral in minutes. The insights have a shelf life. If you can't process that data in near real time, poof, the opportunity is just gone. And finally, there's variety. The data comes in every shape and size you can possibly imagine. You've got your perfectly structured numbers in a database sitting right next to completely unstructured tweets, videos, and audio files. Trying to make sense of all these different formats at once is a huge technical puzzle. So, okay, we've got this ocean of data. What do businesses actually do with it? Well, they try to climb what's called the analytics ladder. You can think of it as a journey, a progression, from just looking at the past to actually being able to shape the future. This ladder has four main rungs. It all starts at the bottom with descriptive analytics. That's all about hindsight, just figuring out what happened. Then you take a step up to diagnostic, which gives you insight into, okay, why did that happen? But the real magic, the really cool stuff, starts at the third rung, predictive analytics. That's foresight, where we start asking, what will happen? And right at the very top, you have prescriptive analytics, which is the ultimate goal. How can we make it happen? For right now, we're going to zoom in on that third rung, the predictive level, because this is where data mining just truly shines. This is all about uncovering those hidden connections and associations that are practically invisible to the human eye. And one of the most powerful techniques here is something called association rule mining. At its heart, it's really simple. It's about finding products that people tend to buy at the same time. You'll also hear it called market basket analysis, and that's for a pretty obvious reason. It literally analyzes what's inside a shopper's basket. Now, some of these associations are, well, kind of obvious. If someone buys bread, it's not exactly a shocker that they might also grab some butter. But data mining is all about finding the non-obvious rules, and that brings us right back to our opening question. A famous, though maybe it's more of a legend at this point, retail study found that if a customer buys hot dogs and ketchup, they are also surprisingly likely to buy beer. Now that is a hidden pattern you would probably never guess on your own. So, how in the world does a computer find a rule like that? Well, it's not magic, it's just a really clever algorithm. So let's peek under the hood and see exactly how a classic algorithm called a priori finds these rules in a small, simple set of data. All right, here's our practice data, just 6 transactions from an electronics store. Our mission, should we choose to accept it, is to find which of these items are bought together most often. Now, just by glancing at this, it's pretty tough to spot any clear pattern, right? Well, let's see how the algorithm does it. To find a pattern that's actually meaningful, the algorithm needs to measure 2 key things. First, is the pattern common enough to even care about? That's called support. It's just a simple count of how often a set of items shows up together. Second, if that pattern does happen, how reliable is it? That's confidence. It asks the question, okay, if a customer bought this thing, how likely is it they also bought that thing? A really valuable rule needs to have both high support and high confidence. Okay, so step one is super simple. The algorithm just scans all 6 transactions and counts how many times each individual item pops up. This is its support count. So we can see here that the iPhone and the Bluetooth device are the most popular, each showing up in 4 out of the 6 baskets. Easy enough. Next up, the algorithm moves on from single items to pairs. It scans the data all over again, but this time it's counting how many times these combinations appear together in the same transaction. So, for example, we can see that the pair iPhone, Bluetooth shows up in 3 separate shopping trips. And here comes the really clever part. It's called pruning. We set a minimum threshold for our support. We basically say, look, a pair has to show up at least twice for us to think it's interesting. So any pair with a support count of less than 2 gets immediately thrown out. This is the simple little trick that makes the whole process so efficient. It just stops wasting time analyzing combinations that nobody really buys. The algorithm keeps doing this, building up from pairs to bigger combinations, and after it calculates the confidence for every potential rule, it spits out the final results. And would you look at that top rule? If a customer buys a Bluetooth device and a laptop, the confidence that they also bought an iPhone is a whopping 100%. And there it is. That's the hidden treasure in our data. In this little data set, every single person who bought both a Bluetooth device and a laptop also bought an iPhone. That is a powerful, actionable insight that was completely invisible when we were just looking at the raw numbers a minute ago. But let's be real. Finding these hidden connections is useful for so much more than just figuring out where to place items in a supermarket aisle. The same fundamental technique powers a huge range of the technologies that you and I use every single day. You know that people who also watched feature on your streaming service? Yep, that's market basket analysis. Banks use this exact same logic to detect fraud by flagging weird combinations of transactions that don't fit the pattern. It even helps in medicine by finding links between different diseases. It's really the hidden engine behind e-commerce, marketing, and so much more. Which kind of leaves us with one final, pretty big thought. We started this whole thing with a simple question about shopping habits, and we ended up with this incredibly powerful engine for prediction. So if data can reveal these complex, hidden patterns in our behavior, what are the limits? If it can predict what we'll buy, what can't it predict?